Now, this is the process that someone had to follow in order to simplify the original trigonometric expression. Here we're trying to convert simply the initial expression tangent of x times cosecant squared of x minus 1. And it has to end up as cotangent of x, but we're focusing on simply one side of the equation, this side. And we're going to work with that side, and eventually it'll turn into cotangent of x. We're given one step at a time, and we have to decide which identity is being used every step of the way. On the first statement, you have the same exact expression that you had on the left-hand side of the equation. Then, from that first step to the second, the only thing that happened was the tangent of x became sine of x over cosine. What identity allows you to do that? Tangent becomes sine over cosine when you use the quotient identity. So what is the rule that we're using here? Simply the quotient identity. So that's our first rule. Now that we have sine over cosine, that seems to be the same from, let's say this is the first step, this is the second step. On our third step, we did not alter that sine over cosine, but looks like something happened to this cosecant squared minus 1. Somehow it became cotangent square of x. So let's try to focus on one identity that involves cosecant squared and cotangent squared. Looks like they use a Pythagorean identity, but not as it is right now on the screen. Looks like someone did some rearranging on that identity, making it cotangent squared. We'll write it in terms of x. Cotangent square of x is equal to, and you can have cosecant squared of x minus 1. So it's just another way of writing that identity, and that allows you to convert anytime that you come across a cosecant squared of x minus 1, it'll become a cotangent squared. So what was the identity used? It was simply the Pythagorean identity. So let's write that down. Now, let's see if any more identities were used at the next step. So once again, let's see what was updated from step 3 to step number 4. So sine over cosine seems to be sticking around, but somehow cotangent became cosine squared over sine squared. So it expanded, but did not involve sine and cosine, sine over cosine. It simply expanded the cotangent into cosine over sine. So let's try to find an identity that involves cotangent, sine, and cosine. So that identity is right here. But that identity can also be squared. So if we square that identity, becomes cotangent squared of x. I'm going to use x once again, equals cosine squared of x over sine squared of x. So that means that they use the quotient identity, but the squared version, or the original identity, but they just wrote cotangent of x squared. That is equivalent to writing cotangent squared of x. So if you think of that, you can just substitute cosine over sine instead of the cotangent, cosine of x, over sine of x. And if you square it, each one of those expression is going to end up squared. And in this case, the squared is written exactly over the cosine and over the sine. So it simply involves the quotient identity. So I'm going to write now. Let's see if someone used another identity from step number 4 to step number 5. So it looks like the sine over cosine is no longer there. So something happened to everything at once. So let's try to zoom in into what seems to have changed. You used to have sine of x over cosine of x. And then here I'm going to write it as cosine squared of x over sine squared of x. So it looks like we only have sine and cosine involved. If you think about it, sine squared is simply a sine of x times sine of x, and same up here. That cosine is simply cosine of x. Let me just make this. That is cosine of x times cosine of x. So if you think about that, you are simply canceling out sine with one of the sines or the squared. So one sine is going away, and this cosine with one of the cosines, or you just remove the squared. So if you look at it after the cancellation, you're going to have cosine over sine. That did not involve any identities. You just had to simplify your original expression. So that means that no identities were involved, just some plain algebra. Now, from that point number 5, point number 6, looks like no more canceling, no more simplification. We simply need to turn cosine over sine into cotangent. So cosine over sine is equal to cotangent when you use a quotient identity again. So we're simply going back to this identity of cosine over sine. Becomes cotangent. Anytime you see cosine over sine, you can make it cotangent, and that simply is quotient identity. So that would be the rules that led to getting a cotangent.